Hello everyone. In this video, I want to talk about three topics in CoppeliaSim, or maybe four. One of them is environment, and environment has several items in it. One of them is the color of the background on the top and on the bottom. The other one is fog, as you can see, and the other one is ambient light. So I want to show you how to change those settings. The other one is applying texture to the shapes like this wall. And finally, we are going to talk about using Lua scripts versus Python scripts. Because you see, so far, all I have used was Lua. So, but you see, when you go and say script and you say threaded, non-threaded, then you can do Lua or Python. And so if you're wondering why you would use Python versus Lua, I want to basically shed a little bit light on that. So let's get started. But let me first show you this. Okay, so this is the Pioneer robot with a Kinect on it, and this is the image. This is the depth, and it is doing its job right now. And you see that the fog actually does affect the RGB image. So how would you do that here? So for doing that, let me create a new scene, right? If you look here, you see that the color of the top of the background and bottom of the background are different, okay? So, and then there is no fog and there is so much of ambient light. So before I add anything else, let me first show you those settings. So here you go to Tools and then you click on Environment. And these are the settings you have. So here you can go to the background at the bottom here, right? And let's say I want to make it black, for instance. Okay, so I can bring all of these guys down and make it completely black, right? You can change any of these that you want and change it. So let's say that. And then for the top part, let's say I want to make it kind of reddish a little bit, right? So bring these guys down right now. Of course, since the top and the bottom of the background are related, if you change the top, the bottom will change. If you change the bottom a little bit, the top would change. But to some extent, you can change each one of them kind of separately too. So here, let's say this is my background, then I can change the ambient light, right? So you can either change the ambient light RGB, or it's better to just change the luminosity, right? Look, you can make it bright, you can make it dark, right? You can add saturation to that light and so on. And you can change the hue for that light. So if you want to use a different ambient light, you can also do that. Okay, right? So here you can do that as well. And then if you want, you can add fog. And this is really good for mobile robots that work outside. You can, if they need to work in the fog, you can add that. So look, as soon as I say fog, now I can do linear fog or exponential or something. And then there is a start distance and a stop distance. But let me first make the color of the fog white instead of black. Okay, so I'm gonna make the fog like this. If you make it black, actually you can kind of simulate smoke too. So let's say this is what I have, and right now the start distance is 0, the end distance is 5. So if I change that, the start distance to 1 meter, you see now I can see a little bit better. If I make it 3 meters, now I should be able to see a little bit further down. And if the end distance, instead of 5 meter, I make it, let's say, I don't know, 15 meter or something. Okay, now I can even see better. So it's the start of it and the end of it. And it's completely under your control to do whatever you want to do with it. So here is basically controlling the environment, right? Now, let me get rid of the fog for a second. So go back and turn it off. Okay, and let's say this is my environment. Now, the next thing I want to bring in is a wall and put some texture on it. So here we go to infrastructure, we go to walls, and we're going to grab some wall here. So let's see. This one should be a good one, this guy here. So here we put the wall down, right? Now that's too big of a wall, but that should be okay. Or if you want, you can pick this one. Yeah, this one is probably not as tall. Let's see if I can find one good one here. Something like this. There we go. right? So right now, if you look, it is basically kind of white, right? It doesn't have much of a texture. But if you open underneath it, you see the mesh file, and you can double click on it. And now this is where you can do the texture. So if you click on texture, it only has a few existing texture. Right here it says tiled, but if you look at it, it's not really much of a tile. I mean, this is the kind of tile that you get. So I want to get something like a real brick wall or something. So here I'm gonna clean this up and either go back to texture and say load new texture, and then I get it a JPEG image that I downloaded from the internet, or I can do a similar thing with the quick textures too. Okay, so let's say I get this one, the brick wall, and not only it applies it to the front face, it applies it to the whole surface. Okay, and that is gonna make this beautiful wall here, right? And now you can add your robot here. I added the Kinect so I can see the RGB image as well as the depth, and there we go, beautiful, right? So these are two of the items that are more about graphics that I wanted to tell you. But the other thing that is more about the script now that I want to tell you is the difference between Lua and Python. So you might be wondering, why did you use Lua so far back to back? Well, there is a reason for that. So let me talk about it. So in terms of the major thing for me is this guy, speed. I wanted the code to run fast. Now, Lua, the good thing about it is it works and runs inside the simulator. It has direct access to the scene, and so it has low latency and it's very fast. So if you ever need to do something that has embedded system that is a fast real-time system or something, you need to run with Lua. On the other hand, Python is accessing the CoppeliaSim simulator externally with the remote API. Okay, so it has its own process. And so because it's its own process separate from the simulator of the CoppeliaSim, it is slower. Okay, so this is not really recommended if you are after running something fast. Now here, there is one word that I want to clarify for you. It's called the IPC overhead. So what is IPC? So the words that I showed here in this table, I want to explain them to you. So IPC is called the inter-process communication. What is that? It's basically a way for two separate processes to communicate. In this case, Python and the CoppeliaSim simulator. Okay, that is how they talk to each other. The method, the way, the mechanism is called IPC. Okay, so it's kind of like an imaginary cable, basically. Okay, then what kind of IPC are out there? There are so many different ones. One of them, if you have seen, they call it socket. So one of the IPC mechanisms called socket. What is socket? It's actually a communication channel that you use in IPC, and the way that it works is by ports and IP addresses. Okay, so a CoppeliaSim script or process listens to your socket, and your Python client dials in to send the commands. Okay, so analogy is like a telephone line. One listens, one other calls, and they talk until somebody hangs up. Okay, so this is one of the ways that IPC works, is by IP address and port between Python and Python is like the client, the one talking, and CoppeliaSim is the one listening and receiving messages. In terms of stability, if basically Lua crashes, since it runs in the sim, it can freeze the sim. So your code in the Lua is not super stable because the crash in the code will freeze your simulator. But for Python, since it's a separate process, your Python can fail, but your simulator can still work or stay stable and not freeze. In terms of multi-threading and concurrency, Python is really actual threads and processes, so it's flexible, while Lua is using what we call a coroutine. So what is a coroutine? And concurrency. What are these? Let's talk a little bit about them. A coroutine, or a cooperative thread, is basically a lightweight function that can pause, that can yield or pause and resume later. I showed you in one of my previous videos how to pause and how to resume, and I showed you when you do a threaded Lua code, it's not, remember I told you that it's not a real thread when you do Lua, because what it does, you are literally just yielding and resuming and so on using those commands. So Lua, as I said, is using those coroutines, so you can go based on those pause and stop and resume. Okay. In terms of analogy, it's like a speaker who pauses in the middle of a lecture to allow the other people talk. So when you have several things running in Lua and you call it a threaded code in Lua, basically the way that the time of the computer or the processor goes to each one of these tasks is when one of them stops, then it gives the chance to the other ones to basically start working. So it's kind of a cooperative, right? One stops voluntarily, then the second one will move on, and so on and so forth. Okay. So this is what we call concurrency. Concurrency is basically kind of like juggling. So you have only two hands, but you have several balls and you're juggling this task. And that is what Lua does. But what Python does is actual threads. So what Python does, you have several hands, and now my painting is not that good, or drawing, right? And each one of them has a separate ball. So they don't need to juggle. But in Lua, you only have two hands and you have 3-4 balls that you're juggling. So this is really, if you want to do real threading and several tasks at the same time, Python is better at that. In terms of debugging, the debugging for Lua is done inside the CoppeliaSim simulator, but for Python, you can just do it inside its own IDE. Okay, so you can use any Python IDE and do the debugging of Python code into Python IDE. Because you have seen in the past, when I run a Lua code, I get those red messages, error messages, down in the status bar, right? And that is all I get to know which line of the code has any error. It doesn't explain much. I cannot put a pause in the code. And by pause, I mean a break, not a pause. And the debugging is really limited in terms of Lua, but Python is much more powerful because you can use any well-known, well-established Python IDE. In terms of the libraries, basically, Lua has minimal ecosystem, but Python has a huge collection of libraries for machine learning, data, and so on. And again, the word ecosystem here means the collection of libraries, tools, frameworks, and community support. Okay, so Lua is not really that big of an ecosystem. It doesn't have that, but Python, it has literally anything you want. So in terms of scalability, of course, Lua is good for small specific tasks, but Python is good for large and modular projects. And as I said, in terms of application, use Lua for fast embedded code, use Python for high-level coordinations, machine learning, data processing, and so on. So hopefully this comparison gives you an idea of when to write a script in basically Python, and when to do it in Lua, as you can see here. So here you get an idea. Okay, so hopefully this video was useful to you, and I'm gonna see you in the next video. Thank you.